Hello students, how are you doing today? I want to take you through the topic gradients and equations for straight line, a paper 1 concept notoriously tested, and I'll be pointing out some of the common mistakes you guys do. I want us to get started. I want to start by defining for you the word gradient. What is gradient? Gradient is defined as a measure of steepness or slope of a line. Gradient is defined as a measure of steepness or slope of a line. The question we should be asking ourselves is, what exactly do we mean when we talk about steepness? What exactly do we mean when we talk about steepness? I want us to consider these two lines. We have got a line AB and another line PQ. Which of those two lines would you say is greater than the other? The line AB is greater in steepness compared to the line PQ. In other words, if the gradients of these two lines were to be obtained, or if we were to get the gradients of the two lines, we then expect line AB to give us a bigger figure or a greater number compared to the line PQ. For example, if the gradient of line AB is to be obtained, and let's say we obtain the gradient, for example, as 4, then it is expected that if the gradient of the line PQ is obtained, what we would get as a gradient is a smaller figure than 4. That's because line AB is steeper than line PQ. So the question is, how do we obtain gradient? Gradient is obtained using what formula? Gradient is obtained using the formula change in y coordinates. Gradient is obtained using what formula? The change in y coordinates all over the corresponding change in x coordinates. It is a change in y coordinates all over the change in x coordinates. This can be symbolically represented as follows: change in y all over the change in x, whereby the change in y in this particular case means y2 minus y1 all over x2 minus x1. That is how to obtain the gradient of a line. Whenever gradient is obtained, I want to bring to your attention that all these answers are possible. You can always get a positive answer. You can always get a negative gradient. You can get a zero gradient. The gradient can as well be infinite, or what we may want to say, undefined. Each of those gradients communicate something special. For instance, whenever gradient is positive, it communicates that a line is sloping upwards. So anytime the gradient of a line comes out as positive, what it implies is the line we are talking about is sloping upwards. Whenever the gradient of a line comes out as negative, it implies that the said line is sloping downwards. Whenever gradient is 0, it implies that this line is horizontal, or what I would want to say, parallel to the x-axis. As for vertical lines, their gradients will always be infinite. So each of those 4 gradients communicate something special in mathematics. So whenever it is positive, whenever it is positive, it implies that the line is sloping upwards. Whenever gradient comes out as negative, it communicates that the line is sloping downwards. Whenever it is 0, it means the line is horizontal or parallel to the x-axis. And whenever it is vertical, it communicates that the line is vertical. Whenever the gradient is infinite or undefined. Take note of that. I want us to learn how to obtain the gradients of lines using the formula we have just given. Let's take the following examples. You are told, you are asked to find the gradients. Find the gradients of lines joining the following points. You are required to obtain the gradients of lines joining the following points. Let's start with this one. A line joining a point A, which is 1, 2, and a point B, which is 3, 8. Let's consider another line joining the point P, -1, 4, and Q, -3, 7. Then let's consider another line joining the point M, which is 3, 5, and the point N, which is 3, 11. And last but not least, we will consider a line joining the point X, whose coordinate is 5, -1, and Y, 7, -1. The reason as to why I'm taking you through these 4 examples is because each one of them will produce unique gradients. And like we have already mentioned, whenever a gradient is positive, there is something it communicates. Whenever it is negative, there is something it communicates. Whenever it is 0, there is something it communicates. And when it is an infinite gradient, there is also something it communicates. Let's consider these examples. I will start with the first one. We have got a line passing through the points A and B, in which the coordinate of A is 1, 2, and that of B is 3, 8. How will you obtain the gradient of this line? We all know that in any coordinate, the first number will always represent the x-coordinate, and the second number represents the y-coordinate. I will strongly advise you to label them. Labeling will help you avoid careless mistakes in obtaining the gradient. So how do we label them? We know that this number is representing the x-coordinate. So I'm going to label this one as x1. Then I will label the 2 as y1. As for the 3, we will label this one here as x2, and this will be our y2. To obtain the gradient of this line, what do? We'll take the change in y all over the change in x, where change in y means y2 minus y1 all over x2 minus x1. What is our y2 in this particular case? Our y2 in this particular case is 8. And what will be our y1? It is 2, which I'll put over. The x2 is 3 and the x1 is 1. 8 minus 2 should give us 6, and 3 minus 1 should give us 2. When the 2 are divided, we obtain a gradient of 3. Like we had mentioned earlier on, whenever gradient comes out as a positive, what does it really communicate to us? It communicates that the line we are talking about is sloping upwards. or what you may also want to call a rising line. It's a line sloping upwards in this manner. We have got the second one. I want us to obtain the gradient of the second line. What is the gradient of the second line? We have got P, whose coordinate is -1, 4. We have got Q, whose coordinate is -3, 7. Like we had already mentioned, in any coordinate, this first number is taken as the x coordinate. So we are going to label this one here as our x1. And this will be labeled as y1. This will become our x2. This is y2. It is generally a safe practice to label these coordinates. It will help you avoid careless mistakes. Take note of that. So how do we obtain the gradient? We'll take y2 minus y1, then put all over x2 minus x1. What is our y2 in this particular case? The y2 is 7, which I'll subtract from the number 4. I mean 4 will subtract from the number 7. Then I'll put all over. What is our x2? -3. I'll then subtract -1. So what will we have in this case? What is 7 minus 4? That should give us 3, which I'll put all over. I want the student to take note of this. Understand the reason why I'm putting the two negatives. The first negative comes from the formula, while the second negative I'm having here is coming along with the x1. That is my reason for putting the two negatives. So what's -3 minus -1? That will be -3 plus 1. Two negatives will always make up a positive. So this will be 3 all over -2. And 3 divided by -2 should give us a gradient of -1.5. What I'm trying to pass across is very simple. Our first gradient was a positive number. The second gradient I'm getting here is a negative. I'm just trying to bring to your attention that gradient can be either a positive or a negative. Sometimes it will come out as 0, and sometimes it will be infinite. That is to imply, if you are to use a calculator, the result you get from a calculator will be a math error, to imply that the operation is not possible in mathematics. So we have already obtained a positive gradient and a negative gradient. I want to take you to the third possibility of gradient. Let's come to the third one. What do we have? We have got a point M, which is 3, 5, and a point N, which is 3, 11. Like we had mentioned earlier on, the first number is the x coordinate. We will label this one here as x1, and this will be labeled as y1. This will be x2, and this other one will be y2. So how do you obtain gradient? Gradient is given by change in y all over the change in x. Talking about change in y, what do we mean exactly? y2 minus y1 all over x2 minus x1. What is our y2 in this case? The y2 is 11. Minus, what is our y1? It is 5. Which I'll put over. What is our x2? Our x2 is 3, which I'll subtract from x1, which is another 3. What is 11 minus 5? That should give us 6. And 3 minus 3 should give us 0. I want you to consult with your calculator and agree with me that 6 divided by 0, the calculator will give you no answer. Confirm with me. So what do we get when we take 6 divided by 0? In the calculator, 6 divided by 0, if you have done it from your end, the calculator is giving you no answer. The calculator is either giving you a math error or not giving you any result for that input. That implies that this operation is not possible in mathematics. This is the time when you say that the gradient of the line is infinite. I hope that has been understood. Or the gradient of the line is undefined. And that will take me to the last example. The reason why I gave you these 4 examples is because each one of them is giving a unique gradient, and I want to expose you to all the possible results you get whenever you look for gradients. That brings us to the last one. What do we have in the last one? We have got x, which is 5, -1, and y, that is 7, -1. We will label this one here as x1 and this one as y1. Then this will become our x2 and this will become y2. How do you find gradient? y2 minus y1. y2 minus y1 all over x2 minus x1. What is our y2 in this case? -1, which we will minus from another -1. I'll put this one here over 7 minus 5. What result do you get from the numerator? This will be -1 plus 1, because 2 negatives will always make up a positive. I'll put this one here all over 2. What's -1 plus 1? That should give us a 0, which I'll divide by 2. And 0 divided by 2 is 0. Gradient can be 0, infinite, negative, or positive. What does a 0 gradient imply? It implies that the line we are talking about is horizontal, or if you like, parallel to the x-axis. I hope that has been understood. We'll then move to the next subtopic under this. I want us now to learn how to find the equations of a straight line. How to obtain the equation of a straight line. Before we get into this one, do take note of this. The equation of a straight line, the equation of a straight line, takes the form of y is equals to mx plus c. The equation of a straight line takes the form of y is equals to mx plus c, where m represents the gradient, where m in this particular case represents the gradient, and the constant c represents what I call the y-intercept. The c represents the y-intercept. I'm going to avoid talking about the y-intercept in details because we want to handle it at some point as a whole subtopic. Let me just concentrate on the part of gradients. For now, I'm just going to give you a shallow information on what y-intercept is through some examples we want to discuss. Let's look at the first example. You are told, find the equation, obtain the equation of a straight line. Obtain the equation of a straight line joining the points. Obtain the equation of a straight line joining the points A, which is -3, 11, and B, 1, 3. Then in my second question, I'm going to request you to sketch the above line. I request you to sketch that line. I want us to obtain the equation of a straight line joining the points A, which is -311, and B, which is 1, 3. The first thing that a student is required to do is to obtain the gradient of the line. The line is passing through the point -311 and again passing through the point 1, 3. How do we find the gradient? Like I've already mentioned, let's start by labeling these points. The first coordinate will be representing an x coordinate, so we will label it as x1. The second coordinate will be labeled as y1. This will be x2 and this will be y2. So how do you find gradient? y2 minus y1 over x2 minus x1. What is our y2 in this particular case? It is 3. What is our y1? That will be 11. Which I'll put over. What is our x2? That is 1, which I'll minus from -3. So 3 minus 11 will give us -8. And 1, remember that 2 negatives will always make up a positive. So this will be 1 plus 3 to give us 4. The gradient of this line is -2. In order to obtain the equation of this line, a student will be required to pick any of these two coordinates. I will go for the point -311. This will be accompanied by a pair of variables x, y. Then this time round, we are also going to make it look like we are looking for the gradient. But ideally, we are not looking for the gradient because we already have it. This time round, our goal is to obtain the equation. So what will we have in this case? I will have, what's our y2? That will be y. We still go with the same original formula. y2 minus y1. That will be y minus 11. Which I'll put over our x2 in this case is x, and our x1 is -3. But because I'll be having two negatives, that will then become a positive. So the first negative is for the formula. This other negative is coming along with the x1. So this should be equal to a gradient, which we already know is -2. We can put it over 1 for purposes of cross multiplication. So what do we have? This will then become y minus 11 all over x plus 3. Where is the positive coming from? Two negatives will always make up a positive. Should be equal to -2 all over 1. We will then cross multiply. When we cross multiply, the 1 will be multiplied by y minus 11, then the -2 will be multiplied by x plus 3. What is 1 times y? That will give us y. 1 times -11 should give us -11. Equals -2 times x is -2x. -2 times 3 will give us -6. The -11 will then cross over to the other side of the equal sign, giving us y is equal to -2x minus 6. The 11 crossing over to the other side would become a positive. Our equation will then become y is equal to -2x plus 5. The second equation, this is the equation of the line. The part A is fully sorted. Bringing us to the part B. In the part B, I'm requesting you to sketch the line if you really know. I want to find out if you really know what each and every figure here represents. The first figure, -2, is a gradient. We already agreed on that from the equation. We agreed that M will be representing the gradient, while C will be representing the y-intercept. So, in sketching the line, it is these two figures that will dictate how our line would be looking like. Let's see. How do we sketch the line? Let's come up with the y-axis and the x-axis. Take note, the key word in this whole thing is sketch. In a sketch, the marker is always interested in the key information being factored into the diagram. What are these key information? One, the examiner will be keen on the slope of your line. Take note, this line is having a negative gradient. We already agreed somewhere that whenever a line has got a negative gradient, the line must be a line that is sloping downwards in this manner. Then what does this 5 communicate to us? The 5 is what I call the y-intercept. What does it communicate? It tells us the point where our line would be cutting the y-axis. So this line is expected to cut the y-axis at 5. And this line is expected to slope downwards. This is how your sketch would look like. That is the origin. We have the x-axis and the y-axis. This is how the sketch would look like. I want to take you through another example, hoping that this one has been well understood. I want us to consider another example. Let's consider this other one. Example 2. I want us to obtain the equation of a straight line joining the points. Obtain the equation of a straight line joining the points P, 3, 1, and Q, 1, -3. Then in our part B, I will again request you to sketch the above line. Sketch the above line. I will look at the first one. Obtain the equation of a straight line joining the points 3, 1 and the point Q, which is 1, -3. How will we obtain the equation of this line? We'll take the point P, whose coordinate is 3, 1, and the point Q, whose coordinate is 1, -3. The first step is to obtain the gradient of the line. This first number, like we already know, represents the x-coordinate. So I will label it as x1. This other number represents the y-coordinate. I will then label it as y1. This other number represents the x-coordinate. So I will label this one here as x2. This other one represents the y-coordinate. So I will label this one here as y2. Now, how do you obtain gradients? It's y2 minus y1 all over x2 minus x1. What is our y2 in this case? It is -3 minus y1, which in this case is 1. I'll put this one here over x2. What is our x2? 1 minus x1, which is 3. Minus 3 minus 1 should give us -4. And 1 minus 3 should give us -2. That gives us a gradient of +2 if the two numbers are divided. We will then move into obtaining the equation of this line. In order to obtain the equation of this line, the student is required to pick any of these two. The choice will be yours. Should you go for the point 31? The point 31 will be accompanied by a pair of variables x and y. Then, like I mentioned, we are again going to make it look like we are looking for the gradient. But ideally, we are not looking for the gradient because we already have it. This time round, our goal is to obtain the equation. So I will still label it the way we did the other one. This will be x1, y1. This will be x2, this will be y2. I'm repeating this again. We are going to make it look like we are looking for the gradient. But ideally, our goal is not to get the gradient because we already have it. This time round, our goal is to obtain the equation. So I'll take my y2. What's our y2 in this case? It is y. I'll subtract from our y1, which in this case is 1. I'll put all over x2, which in this case is x. I will again subtract from x1, which in this case is what? 3. So I will say should be able to give us a gradient which we already know is 2. Allow me to put it over 1 for purposes of cross multiplication. So I will cross multiply. The 1 will be multiplied by y minus 1. Then the 2 will be multiplied by x minus 3. If possible, I will advise the student to always have the y on the left-hand side. So what do we have? 1 times y will give us y. 1 times -1 will give us -1. 2 times x will give us 2x. Then 2 times -3 will give us -6. This will be y equals 2x minus 6. I'm going to carry the -1 to the other side of the equal sign to become +1. So this will be y is equal to 2x minus 5. That will be y is equal to 2x minus 5. That becomes our answer for the part A. Which brings us now to part B. In the part B, I have again requested you to sketch the above line. How will the line look like if we sketch it? Let's try sketching the line. To sketch the line, I'll come up with my y-axis and the x-axis. Take note, the keyword here is sketch. When sketching a line or when sketching a diagram, focus less on the beauty and more on the key information being factored in. What are the key information? The gradient communicates the direction of slope, while the -5 will be communicating where the line is crossing the y-axis. We already agreed that m represents the gradient, while -5 represents what I call the y-intercept. So what does this y-intercept communicate to us? The line is expected to cut the y-axis at -5. What does the gradient 2 communicate? The gradient 2 communicates the direction of slope. Whenever a gradient is positive, it communicates that a line is sloping upwards. So that is how the line is expected to look like. This will be our x-axis. We've got the y-axis. And avoid putting too much information in a sketch. That is for today. We'll be discussing more in our next session. Have a good night. Have a good time.